Dear colleagues, good afternoon. Let us continue our session, System of Information Security. Yes, maybe we will wait for 3 maybe minutes for waiting for joining us, our colleagues, and we will start. The first presentation, please prepare our colleagues from Turkey. Greetings from Ukraine. Nice to meet you here. And it will be Sedat Akleylek. Are you ready?
Yes, I am ready. Thank you very much for your presentation.
Okay, please start. You're welcome.
Okay. Thank you very much for your kind invitation for this conference, and it's very important for us to collaborate with you. Let's start with the presentation. My name is Sedat Akleylek. I am working at 19 Mayıs University, Department of Computer Engineering in Samsun, Turkey. We are very close to Ukraine here. We are neighbor in the Black Sea region. The title is GPU Implementation of Quantum Secure ABC Crypto System on CUDA. Here is the outline. First, we will talk about post-quantum. Then we will give some information about multivariate polynomial systems. We will define our motivation and contribution. Then we will give some information about ABC crypto system. We will give some details on the implementations, both in CPU and GPU. We will provide a comparison at the end. We will give our conclusions and possible future works. Now, first, we have to know that what is post-quantum cryptography. We need to know post-quantum cryptography does not the same with the quantum cryptography. Here, our aim is to find quantum-safe public key systems. And we believe that post-quantum cryptographic schemes are secure against quantum computer attacks. Post-quantum systems relies on the mathematically unproven assumptions. We call them NP-hard or NP-complete problems. However, some of them has been solved. If you have a system whose security depends on integer factorization or discrete logarithm problem, then those are not quantum safe due to the Shor's algorithm, which was published in 1996. So NIST, National Security Agency of USA, has started a competition for the standardization of the post-quantum crypto systems. It was started in 2016. Now we are continuing to select the standard systems. We know that there are so many attempts to build a quantum computer. There are so many companies, for example, D-Wave, IBM, Google has quantum computers, and they are building more computers. Now we can recall the multivariate polynomial systems. Why we choose the multivariate polynomial system? This is quantum safe system. It is not easy to solve the multivariate polynomial systems even you have a quantum computer, since we don't have a polynomial time algorithm to solve this kind of polynomial systems. The meaning of multivariate polynomial systems, we have at least 2 different unknowns. Then we build a system. It is not easy to solve. If it's a linear system, it is easy to solve. And how we can build a signature scheme or an encryption scheme by using multivariate polynomial systems is you first find your message to encrypt, then you are using the public key of U, then you will receive the ciphertext. Here the ciphertext is Z, our public key is P, our message is D. Now we need to decrypt the message. How we can decrypt? Public key is the composition of S, F, T. S and T are the linear maps. F is the central map, and it has nonlinear property. It makes the confusion in the text. And we have just a map, SFT map. Then we have to find the inverses of these maps. S and T are the linear map. You can think about them as a n times n matrices. Then you have to find the inverses. But F is a nonlinear equation, as in the multivariate polynomial system. And our implementation is, if you have a standard in post-quantum world, you need efficient implementations. If you have efficient implementation, then you can show that this system can be used in our daily life. Now we are using RSA to encrypt key or to sign a message, or ECDSA. Now how we can change these algorithms in our daily life? We need a library to implement them or to serve the others. And we have also need some implementations in CPU and GPU. You know, GPU has a parallel processing capability. Then you need to make parallelization for this. Let's record the ABC system. It's very easy system. You need some linear elements, also some matrices. These matrices gives the name of the system, ABC. We have n times S matrices here, ABC, and those are called this system. Note that n is equal to S square. Now we need some maps. The maps L2, F, and L1. L2 and L1 is the randomly chosen linear maps, and we have to invert them. Those are matrices. F is the central key, and it's a central map, and it's a non-linear map of this. Encryption is very easy. You just put your message into the equation. The equation, the degree of equation is at least 2. Then we call this example as a quadratic multivariate polynomial system. However, the encryption is more hard. Why hard? You have to compute the inverses of each map, L1, L2, and F. Since L1 and L2, n times n matrices, then you can easily convert, you can easily find the inverses. However, it is not easy to find the inverse of F. Since it is not a linear map, it's a non-linear map. So you have to compute another operations and you have to check some elements for this. And it is not very nice algorithm. Let's think about the ABC system and how we can implement them. Which parameters do we need? We need S, N, and M. Also, we need to compute the public key size and secret key size. Central map size is also important. We use S and N to build the linear maps, which are our secret keys. Now, in this paper, we compute the number of additions, subtraction, multiplication, and other operations to encrypt a message and to decrypt a message, as well as for the key generation phases. And it's very important for us since we compute the number of operations, arithmetic operations, we can easily understand which part is easy to implement and which part is hard to implement. When we think about the CPU and GPU, we have so many differences. In CPU, we have a control unit and arithmetic logic unit. We can send the instructions to the CPU from the RAM. Also, in GPU, we need to implement the parallel operations. We need to make the algorithms in a parallel way. You see an easy implementation, an easy work for the GPU implementation. In this work, we use the CUDA library to continue fast. And it is almost the same in C language. However, you have to use the addresses for each element. And you see some examples for our code. Since I am running out of the time, okay, we received the experimental results in 3 different platforms. In these platforms, all of them has a GPU card, and we have almost the same operating system. If we check the experimental results, the last computer has the best implementation results. However, the memory usage of the implementation is the best in the first computer. We also compute the encryption and decryption timing results for both CPU and GPU. When we check the results, CPU implementation is slower than the GPU implementation, since in GPU we make the parallelization. However, we cannot parallelize all operations. It's a drawback for us. If you can make the parallelization for each algorithm, each arithmetic operation, then the results will be much more better. As a conclusion, we implemented the ABC system on CPU and GPU. We compute the number of arithmetic operations, and we give some experimental results. The experimental results are computed by running at least 1,000 times. Then we take the mean and median values for each of them. We understand that the memory consumption of the CPU implementation is larger than GPU implementations. And by using our library, we would like to add other quantum safe crypto systems in our library. Thank you very much for your attention. If you have any questions, I would like to give an answer. Hello?
Questions, please, Sergey?
So I have no question, but I want to congratulate my colleague Sedat, because I see where is your town Samsun. Is your town Samsun? Yes.
Yes.
It's directly opposite Crimea, near Black Sea.
Yes.
At the other side of Black Sea. It's very interesting to me to see, because I never listen about this town. So it was very interesting to see. And what university?
19 Mayıs University. It's 19 Mayıs University.
It's named by who is named by him?
Okay.
No. By who is the? So
I see.
don't know.
When we translate 19 Mayıs mean 19 May. It's a day. Maybe you know Atatürk yes. started to construct the Turkey at that date and from Samsun. And it's a historical date for the Turkish Republic. So the name comes from this.
Thank you. Thank you.
Thank you very much.
Okay, thank you. The next presentation will be held by our next speaker, Irina Moisenko and her team. Maybe Ivana Druniuk will be a speaker, yes?
And I have a video. Can I don't know
yes,
how.
You can share your screen and play it.
So I'm try. And do you have this video or no? Because
if you send it to
I sent, but I don't. So just a moment.
Okay.
Share a screen, and I try to.
I have the video. I can share screen.
Maybe Tatiana, please share the video because I don't know how to prepare it.
Okay. Can you see my screen?
Yes.
Yes.
Dear ladies and gentlemen, I'm glad to show you our investigation, adaptive models of automated compressed image recovery implementation for video surveillance system as information security improvement. This investigation is a joint work with Lviv State University of Internal Affairs, Lviv Detective National University, and Vasily Stefanik Carpathian National University. My name is Ivana Druniuk, and I am glad to show you our investigation. At first, I want to show you our agenda. I say some introduction, main goal of our investigation. Also, our investigation based on generated adversarial network. Then, and I say some words about this neural network. And after that, I present our investigation that software for video surveillance system. And most important for this software is training for GAN. And after that, I show you some results and some discussion and conclusion. Our inspiration that was the photo of cats that never been in real life, images that generated by neural network. These images also shows that the artificial intelligence is a powerful tool for many tasks. Also, you can show the images of faces generated by neural network. There is our inspiration. These images was created by Google. So I want to say some words about generative adversarial network. This neural network was proposed in 2014. This is the method of machine learning without teacher that of generating new data, the same statistical parameters as the training set. This result is achieved as a result of a game with a zero sum of network, generator and discriminator. In this architecture, it's possible to restore the original high-resolution image from a low-resolution compressed image. This idea we want to use in information security in banking. And for this, we create a special software. We think that in future video surveillance systems have to be more smart. As I say, the was created in 2014, and for this 6 years, GAN has many successful implementations, such as GAN is used to improve astronomical images, simulate gravitational lenses for dark matter research, and reconstruct three-dimensional models of objects from images, and model motion in video. So this network is very useful to increase the person photograph, to create person photograph, and to improve the photo quality. But using GAN has one special problem, which is the stability of educational process. The main goal of our investigation is creation of software with generative adversarial network for purpose of recognition of small details in video images for surveillance systems. In this slide, you can see the three components of our software. One component is the general, that is interface of our software. Second component is a training, that using for training, and third component is using for modeling images. Next slide shows us the packages using for creating our software. So we use this standard packages for creating our software. And here we can see the detailed block scheme of game training. We use images database from internet database, and start training. For start training, we should create all our images in the same size. So the initial parameters and loading images from database, and the next step is processing of data images, and after that we standardization images size and start new epoch for training our network. During this training, the discriminator and generator doing something that I said in the previous as a game with discriminate and generate. And after that, they generate images. And when the found epoch is reached, we finish our training. As we do this training, we use 7,000 images from USPCP image database, and in the next slide you can see the result of our training. The first one is the historic image, second one is original image, and it's very important the criteria comparison the bitmaps. So we use the criteria as the bitmap criteria. And in the next slide, you see this images creating our one network. And as you can see that the recovered image one is has better resolution than original image 2. And also the map criteria shown in the that image proves this result. So, conclusion from our investigation. The software for automated compressed images recovery using GAN network is an important part of our systems for security. We propose use bitmap criteria for the last function. Compare the pixel similarity of the restored map. This technology proposed in our investigation is very promising and requires the further research to increase the level of information security in video surveillance system. We use only 500 epoch in our training, so the increasing of number of epoch is one of the way to improve our investigation. Another way is the using the images with size, because we use the limited size in images. We think that proposed method in our investigation can be used in many other fields for improving security in many fields. Thank you very much for attention.
So I'm here and I can answer the question.
Okay, please. Does anyone has some questions? Colleagues? No, due to lack of time, let us go on. And the next presenter is Miroslava Bublik. Please, are you ready?
Yes, I am. I'm here. Let me start my presentation.
You're welcome.
Do you see?
Yes.
My presentation? Yeah, thank you.
Okay.
Ladies and gentlemen, let me introduce our research on the assessing security risk methods on e-commerce system for IT portfolio management done by Miroslava Bublik, Victoria Висоцька, Любомир Черун, Valentina Panasiuk, and Oksana Brodyak at Lviv Polytechnic National University, Ivan Franko National University, and Ternopil National Economic University. This project, the main method and means of assessing the risk information security system in the field of e-commerce, IT projects and programs, and the ways of reducing the risks. As a result, we propose the prediction of the results of massive risk trains in e-commerce system. Such prediction can still made with respect to a pair the sampling based on the classical definition of probability that is provided if the experimenters is relatively limited in size. Portfolio management of IT project is the application of traditional management to a large class of objects managed using information technology capability. An example of an IT portfolio would be planned invitation projects and ongoing IT services, for example, such as application support in e-commerce system. The global IT portfolio management will be quantify the previously mysterious effects of IT, thereby measuring and objectively evaluating investment scenarios. In most cases, portfolio management of IT project is carried out through the creation of two portfolios: application portfolios and project portfolios. The subject area of the research in the security risk assessment of the respective portfolios of e-commerce often significantly increases the success of the implementation of the relevant IT project and programs. Information security of e-commerce system means the protection of information and the infrastructure that support IT from accidental or intentional influence of a nature or artificial nature capability of harming and owners of users of information. When investigations, the mechanism IT system treatment, the results of a separate risk assessment, the recommendation are not significant. The study of the interaction of system, norm and situation is explored by means of the probability theory models, which involve the implementation of a mass experimental in which the same trees of information security events is repeated many times. This repeated test from series in which each event occurs or does not appear a certain number of times. Under the term of the first scheme, we can prepare the number of times. Under the term of the first scheme, we can complete the event is considered to repeat after some 3 time after the result of the each trial is recorded in the protocol, which is subsection studies the probability of occurrence of particular events remain unchanged. Investigation information security treats in conduction risk assessment uses a serial surveillance method. It's essential that the group select for units for treats from fixed lines, for example, 3, 5 treats, events, etc. The units of treats that make up series that not necessarily carried out by the one, they may also be executed as an interval of time. When solving many theories engineering problems, you often need to know the likelihood of certain number of certain units of treats and series. If the risk tests that form a series are considered independent, then we can make the necessary prediction using three systems of dependent tests designed in the theory probability: simple polynomial, and Poisson. A simple scheme involved only two results for the experimental, where A or not a pair, and in the Poisson scheme, independent test via performs for several sets: interruption, interception, notification, phase, and each has a different probability. In the polynomial scheme, the test gives not two but several results. At that we have the set of threads. Now, suppose that in some e-commerce system, entries are proposed in terms there are m dangerous threads and mn insignificant dots according to the resampling scheme. An independent test carried out which consists of sequentially random fulfilled treatments for the list of possible ones. It is necessary to terminate the probability of an event, which is an amount of the n treats made, and x this will be dangerous, and the order of the following dangerous are insignificant treats indifferent. The probability of occurrence of event A is equal to x time in series and independent real and formula where P minus Q is equal to. Now also that the probability are equal to the corresponding member and to the schedule of the formulas Binar's experience Q plus P powered on n using expression, call it the Bernoulli formula. The probability prediction results is performed in the simple dependent test scheme. In practice, information security when often has to deal with such a set of threads in which the transaction that make belong to different types of trees, which is constructed in this figure. Now we have different types of trees which is constructed, and at the list of trees we build based of different norm when each of the trees has its own priority probability at each list. As a result, the probability of the occurrence and no occurrence of certain units varies for experimental to experience of e-commerce system. It can be shown that the probability of occurrence of result A in a series n in trial with x times equal to formula. For determining the characteristic for a period of systematic attack of information security e-commerce system was random selected 10 times several for 10 attacks each. Thus, frequently, if successful attack of these series are given in this previous table, and it is necessary to calculate the theoretical binomial distribution or probability of x successful attacks for one series. Here, S is 100 and is 10. Using the product of x and s given in previous table, we found that p is equal 0.44. Attacks of 9 and 10 in the series have amount no effect to the results, therefore can neglect them. The dependence of the value of the expected number of the attack series samples is presented in this figure. The binomial probability distribution of series attacks is presented in this figure. And the Pareto diagram of the distribution of the serial attack in this descending order, and on the axial axis the line of the set of value of the presentation of the total presented in this figure, and the required value is calculated by this formula. And the conclusion: the parents to analyze for a quantitative absolutely request attack series for the system per a certain period, and quantitative related frequency of attack series on the system per certain period, characteristics to assess the information security risks in e-commerce system is proposed. The problematic point is application portfolio management in ensuring for information security of the content analyzed. It is proposed to use the method for the sequentially monitoring to study information security threats and conduct risk assessments. The mathematical model of risk, which provides the result of the test for the hypergeometric law in the base for the construction of the probabilistic model, including those that are widely used in the study of the threats to information security. The analysis clarified the priority of information security allows residual risk and cost of information security measures, and it has been experimentally confirmed on 10,000 samples out of 10 attacks. That is 8,507 samples. No more than 8 attacks can be expected by the great load on the security system falls on 2 or 5 series of attacks. Thank you for your attention.
Thank you, Miroslava. Dear colleagues, any questions?
May I ask the presenter?
Yes, Thomas, please.
Could you tell us what data did you use for experiments? There were real data or some data set?
No, it is real data. Some gather it by situation when we have this one private e-commerce shop. Yeah, we have some system, e-commerce system, and we have get this real data. It's not data set.
Okay, thank you.
Thank you very much.
Thank you. Any more questions?
Yeah, one question.
Please.
So what do you intend to do further? So what is your further research?
By means
according to your results that you achieved at the moment, what is the
I think that if I understand you correct, that we have first idea one hypothesis, and then we look for results. Yes, it was our way for investigation.
Okay, thank you.
Okay, thank you, Miroslava.
Thank you.
Okay, our next presenter will be Alexander Timchenko and his command, his team. Are you ready, Alexander?
Yes. 1 second presentation.
Okay.
Yes. Yes.
Alexander, we do not hear your voice.
Звука нет? А почему звука нет? На, садись.
Okay.
Hello?
Can you hear me now?
Yes, please.
Yes. So, dear colleagues, we are presenting the presentation on the architecture of the simulator of the personal local wireless networks and the examples of the implementation. Should I read the participants or move on to the presentation?
Continue, please.
Yeah, okay. So the contents of the presentation will be divided into introduction, some related works, ground analysis, architecture of the simulator, experimental results, and the conclusion. Introduction. So one of the main tasks that developers of the sensor and specialized networks face is ensuring the scalability and the necessary parameters of reliability, durability, and network performance. We have analyzed several models to simulate this, which include creation and the simulation of a complete model of system, and creation and subsequent simulation of a model containing stochastic elements. The first option allows us to simulate the behavior of each of the network nodes in detail over time, as well as to simulate the movement of packets in detail of the routing. But the second option is optimal for obtaining general characteristics of the network, such as the connectivity of the communication graph, the average number of neighbors for each node. To determine the general characteristics of the network consisting of a large number of nodes, which is typical for any wireless network, the second method of modeling was used. The fact of this approach led us to a possibility to build a statistical model which allows decreasing the complexity in hundreds of times. We have analyzed the related works, and this represents the graph where the proposed simulator compares to other well-known simulators on the same topic. Here's some couple of points of the architecture of the simulator. The analysis of existing software products for simulation of contraction methods and control of sensor topology and actuator networks of wireless access allowed to reveal advantages, likes, and means of improvements. This led to the development of the SNOW simulator, Sensor Network over Wireless. The SNOW program is a simulator designed to study network formation and reconfiguration processes, topology control, routing methods in the IS, distributed algorithms for the operation of nodes and wireless communication protocols related to the channel, and algorithms and methods of building IP as a part of local area network with wireless access. The simulator program provides graphical shell to adjust parameters for the experiment, saving configuration files, and the experiment results display in text and graphical formats. Here we have a control element as a part of the simulator architecture. This displays basically modules of the program. We have radio device specification and control model, network device specification, power model, and transmitter power specification. This is the behavior description of the model and the components, basically. Here we have some main classes of the program and the dependency graph with different types of nodes. This is the simulator interfaces and their dependency topology, and some environment model with its connections. On this slide, we see the actual simulator graphical interface introduced in the program. It has the main window, node generation window, and settings change window, which allow us to change the experiment variables and the parameters. And then the output, which is the simulation window and communication graph. The simulation window consists of tabs to observe removed characteristics and area of real-time graphs, characteristic display, the progress of the experiment, time spent on the simulation, and simulation control options. In this table, we are comparing the two runs, a couple of actually runs depending on the network size, but the main comparison here is between the parallel and the sequential runs. On the next slide, we will analyze the more on a better graphical chart. But the k-neighbors method that was used here involves the building a network based on a certain minimum required number of each node neighbors, which ensures the connectivity of the communication graph. Here's the same data represented on the chart. We can see a drastic improvement with the growing number of nodes for the parallel execution. On this chart, we see the experiment run for the topology of a level 3 in the network. On this chart, we can see the total energy in the network with time for each run. And here we come to a conclusion. So the wireless network simulator building method adapted for the research on the process of building, forming and reconfiguring the network topology control, routing methods, and maintaining wireless network connectivity was considered. The simulator allows to explore the distributed algorithms of the node operation of wireless sensor network protocols related to the channel, network, transport, and session levels of OSI. The simulator implements all the requirements, which are determined from the analysis of the advantages and disadvantages of existing simulators and described in section 3, which provides the necessary environment for experiments to build and study sensor networks. The structure of the simulator program in which the network model is implemented is described in details. Components, classes, interface, environment models, and simulator implementation are described. Thanks to the modular architecture, it is possible to use any new model for a particular component. There is a graphical shell for the study parameters, adjustment, and text displaying in textual and graphical form. Graphics of characteristics in real time, location map of nodes, coverage areas, and communication graph. The examples of work with the simulator are given. One of the simplest ways to build a wireless network is taken as an example. Methods of optimization and description of the method for network constructions are proposed. Thank you for your attention.
Thank you, Alexander. Dear colleagues, any questions, please?
I have one question. Could you compare your wireless simulator with other available similar simulators?
Yes, one moment. Yes, we actually did, and we compared with some of other well-known simulators.
Yeah.
And on different scales.
Thank you.
And may I ask?
Sure.
May I ask a question?
Yes, of course.
What is the main feature simulate wireless? Тобто, яка особливість, що, власне, безпроводові використовуєте for wireless network?
I think that the main idea here is that to have a sensor network, and sensor network cannot function with a cable. It should be wireless.
Mm-hmm. Mm-hmm.
It's the sensor which is the pivoting point here.
Mm-hmm. So you are modeling the sensor поведінку, та поведінку сенсорів.
Yes.
Mm-hmm. Thank you.
Thank you.
Okay, thank you.
Thank you very much.
Please close your presentation. The next presenter, I suppose, will be Lubomir Sikora or someone from their team. Любомир Сікора, Ростислав Ткачук, Наталя Лиса, Іван Дронюк, Ольга Федевич, or Roman Tkachuk, who is here.
Maybe the authors have connection problems. We have a presentation, video presentation.
Okay, please play it.
Can you see my screen?
Yes, everything's okay.
Okay. Very bad sound, yes?
Yes.
And the next step, the system has to be able to control interaction from the moment in the front of the diagram to which interfaces the static situational diagram. And the next step, the diagram provides the interaction and the energy activity of the system. And energy activity focus is the complex information of the dynamic information and simplifies of the structure in the past, let's say, let's say this factor is the appropriate time for action. Accordingly, the actual failure should be associated with the active and productive. The action mode, and the time is involved in I, and action of the entity that is structured is flexible, that has the right scenario, and identifies diagram for the situation, the situation, and the function of the structure. Other than the is attached in the attachment of the customer to the function. The second section is of the structure by motion, which has analysis character and value to do exactly the function that gives to the risk level of the structure of the risk function depends on the logical type and variable and the popular type. Addressing the change in the risk level and the load and the size that at least is the next step to shut down the decision level. In other cases, under the influence of the fact the magnitude of the low risk level risk to the concept of public. Consider the information model for relation diagram, which is change situation. Discuss the change in the management concept, energy active structure, and active control actions, and pathway examples of this way. The change in the situation the general cycle, under the extent of the action against the installation of the control, the change in the capacity of the executive to modify the identification of the project and part of the
Okay, let's move on. The next presenter will be Andriy Nichiporuk. Are you ready?
Yes, yes, yes. 1 minute, please.
Okay.
Dear present, I'm going to present your report on the topic application of multi-factor analysis for the purpose of detection malicious software implants of the software in a local computer networks. My name is Nichiporuk Andriy, Associate Professor of Computer Engineering and System Programming Department of Mlinsky National University. Hidden apps or malicious implants are the most active mobile threat category, generated almost half of all malicious telemetry in 2020, a 30% increase from 2018. Thousands of apps are actively hiding their presence after installation, making them difficult to locate and remove, while anything victims with invasive ads. We will consider in our work, we will consider the software implants that use undocumented software features on the local computer networks of enterprises as an object of research. The difficulty of detecting such secretly functioning software object is due to the absence of its activity during a long time. One of the primary tasks that need to be addressed is to develop appropriate methods for creating effective component of a comprehensive system for detection software implants on local area networks. We detect software implants that use undocumented software feature by manifestation which are based on a file analysis and network activity. These features are presence of software models that do not meet for the purpose of the process, presence of operation system objects that are opened by the process but do not conform to the purpose of the process, high intensity of input-output operation for a certain process, high CPU or internal memory usage from a certain process, the similarity of the file name to the system file name. The operation system process executable file is not in the common directory. The system process is run on behalf of the local user. Code enforcement in the data area, which is enabled for all processes, is disabled for the certain process. The system process has a directory or author than what it must be for that process. The absence of digital signature in the executable, high network activity of the process which must run locally, and else. The basis of for our research is a matrix of observation X. In this matrix, X with index I, K is the number of manifestation of K feature in the I object during the observation period. N is the number of feature, omega is the number of object. The first stage is in our work is a normalization of feature in the matrix presented matrix and its transformation into matrix Z. The expert constructs a squared matrix of n by n pairwise comparison of feature, which has the property of inverse symmetry. Eigenvectors of priorities are calculated, for which all elements of row are multiplied and the root of n degree is taken from result. And then the received number is divided by the sum of such numbers of a column, and estimates of a vector of properties are received. The matrix n is multiplied by the column of the priority vector, and a column with vector y is obtained, which shows the degree of importance of each feature. Then, before the transition from the matrix X to the matrix Z, the result of observation in the matrix 1 must be multiplied by the coefficient y with index k respectively. Next, we built the matrix Z by using such transition as with equation 2. As the difference between the current and average value of the feature to standard deviation of the feature k. Then the distance between the points units of the matrix Z and the points is determined by the formula 5. At this distance, the indicator of the presence of software implants is calculated by formula 6. The indicator d asterisk with index I can be in range from 0 to 1. The closer this value is to 0, the more likely it is that there will be no software implants in facility. The indicator is used to statistically characterize a set of objects. For a more in-depth analysis, it is needed to consider the dynamic characteristic of a single object and then a set of objects. Then, based on the result of observation for several periods of time, a matrix of observation X is formed for one object. In this matrix X with index I, k, the value of the feature k in the period I. So now the indicator d asterisk with index I describes the dynamics of changes in the sets under study, but for one object. We can now proceed to the dynamic characterization of a set of objects. If we denote the observation matrix of an object J by a symbol X with index J, the aggregate matrix for object will remain as a block matrix. Thus, the generalist index d asterisk with index I for all objects in network is determined by equation 16. Then the dependence for the square of the distance for aggregate indicator and the square of the distance for individual indicators can be written as the sum of all C. Taking into account the dependence between aggregate and individual indicators will remain with for equation 18. The obtained formula allows to estimate the influence of individual taxonomic indicators of object d asterisk with index aj on the general taxonomic indicator of the set of object. Here, as before, this is indexed in range from 0 to 1. So, in order to we conduct several series of experiments based on distributed system for detection value. Software implants that used undocumented software feature were developed as a part of each of a typical botnet. The purpose of the experiment was verification of the botnet's detection method, the efficiency of the classifier in the structure of the distributed system, and determination of the dependence of percentage of detected nodes of botnets which had contained software implants. To perform the experiments, 28 botnets and codes of known detected botnets were constructed. The experiment was conducted for the classifier without adding instance of created botnets and with them. That is, the check was performed without training the classifier or the created samples and with preliminary classification of the samples by classes. The monitoring time of a computer system in local area network was 35 hours for each instance of the botnet of each of two classifiers. It should be noted that the functionality of the botnet nodes was simplified and did not include the attack option in their functionality. The experiments involved identification the following metrics for the detection of bot nodes. They are presented on this slide, and you can see there, and I do not read them. The result of the experiment showed that 65% of the test samples were correctly classified for the classifier without the introduced vectors of artificially formed botnets, and 87% for the classifier to which the vectors were previously added during his training. The percentage of functions that the distributed system used to detect botnets and associated with the manifestation of software implants is approximately 26.7% of the total number of detected. The intensity of manifestation of software implants is much lower than the typical manifestation of botnets. These software implants that use undocumented software capabilities in the botnets can be detected by distributed system, and the direction of such research is promising. Thank you for your attention.
Thank you, Andrei. Colleagues, do you have any questions? No questions. Andrei, I have one question. Did you evaluate computational complexity of your method?
No, we didn't take into account complexity evaluation. We focus only on accuracy metrics and efficiency metrics.
Mm-hmm. I see. Thank you. Okay. Any more questions, colleagues? No. Thank you, Andrei.
Thank you.
Okay. Please close your presentation. And the last but not the least, the team of Sergei Surkov, Alexander Martinyuk. Please, are you ready?
Hello, I'm ready.
Okay, you're welcome. Please launch your presentation.
Okay, just one moment. I'll reconnect. I'm sorry, I had to reconnect, but Zoom asked permission to share my desktop. Do you see my screen?
Yes, we do.
Oh, great. Then shall I start?
Yes, you may. Okay.
Okay. Topic of my paper is authentication and request processing model in high-load modes for IT components. And first, what I want to mention is the importance of the authentication of request payloads. And I want to start with TLS protocol. It's a protocol that is used for encryption and identity verification all over the internet. And it's used for transmission of the data due with public networks. And in this slide, how TLS is supposed to work. It should work through all the intermediate nodes from the client to the server, and all the traffic between it should be encrypted, and there is no weak nodes. But in the next slide, there is how it actually works. In the beginning, there is a forward proxy, which is quite often used by companies which may substitute certificates of the websites. And there is also a reverse proxy, or what's also it's called a load balancer. And it's used as an intermediate node between the load balancer and the destination server, which processes requests. And between clients and forward proxy, there is a weak point, and between reverse proxy and servers, there is also a weak points where botnets can do harm. And that's why signing the data during transmission is important. The next thing I want to talk about is operation queues. First thing that I want to say is it's used for an efficient multi-threading processing of operations, and the first thing that I want to say is an operation queue. It's a thread that processes operations that are in the front of the queue, and the operations which are in the back of the queue are put by software. And this operations queue may work with multiple threads, as you can see in the second example. And do you see what's in the right part of the screen?
Yes, we can see your
oh, great, because I see Zoom in the right part of the screen. And then there is a structure of an operation which is enqueued, and it's basically in OOP terms an abstract class with one abstract method to execute a function, and that's all. And what the problem is with the operation queues, it's the high load modes. And here is an example of high load mode that these operations can accumulate in the queue, and memory consumption can be quite high, about 12 gigabytes if not any measures are used to prevent it. And the aim of this work is to improve the performance and to reduce the negative effect of high load modes in operation queue environments. So first thing that I want to talk is the methods which are currently used for signing the data during transmission. I call it filling the buffer. types of methods. It's methods like buffering to memory or buffering to drive. It's basically used to fill some kind of buffer until the transmission is completed, and then this buffer is used to calculate the digital signature, and it's processed further. And the protocols which use this technique is OAuth 1.0 and HAWK. It's an extension of OAuth 0.0 by the same author. And we proposed the model of authentication of payload by chunks. It uses the feature of digital signature method like SHA-1, SHA-2, and it authorizes only chunks of the data, and after chunk by chunk, it authorizes and digital signature is calculated gradually, not it isn't required to be buffered somewhere, but it's calculated gradually, and it allows the developer not to read the same file again, even if the main use case of server APIs is to upload a file to server and then to verify its digital signature. And here you can see the flow of this method that from socket it transmits and to update the digital signature block, and it's written to file. And you can see on the left the flow chart that how the data from the network stream is read. And we also made a communication model for Internet of Things components, which differs from existing one by the ability that and clients and servers can process the requests. And in order to prevent high load modes, we basically did that we limit the request amount of requests per server that we did in our previous method, and also we limit the total network connection speed, which we also find in an experimental way. And here is our model, which we use. The main component is high load mode preventer. Then it goes to asynchronous processing, then authentication of chunks, and then to request handler, and then it writes back to the client. And here you can see our software component which we have developed. It's consists of connection handler component which takes all the connection handlers and goes to request verification. And there is also the possibility to handle these requests on the client side. And the main thing which we did in this paper is that we developed a model which prevents high load modes, and it allows, as you can see, it's an example of high load modes without any measures of preventing it. And here you can see the effect of the limitation of network bandwidth. that it helped a lot to prevent the high load modes. There is only one spike up to 240 megabytes, but it's still not enough. As you can see that here we increased in number of clients and the number of spikes increases. And in this slide, we decreased the maximum number of clients, and the memory consumption went back to normal. And in areas of application, we see that not only Internet of Things devices, but also automotive head units and powerful servers and low powerful devices as ESP8266 that can be used in order such features like updating the firmware can benefit from our chunking authentication. And as a conclusion, we developed and researched and found that developing new authentication methods for large payloads is a relevant task. And we developed a model and methods of authentication payloads by chunks which are meant to be large, and also an analysis of chunking methods showed an advantage in performance comparing to existing ones. And also previously we developed methods of load balancing, and here it improved it further, and also the main what we did here is authentication and request processing model was further developed, and we conducted experiments which showed the capability of mitigating high load modes in the research situation. Thanks for your attention.
Thank you, Sergey. Colleagues, do you have any questions?
Could you tell us, please, what way of authentication did you use?
Right now, we use only HMAC authentication, but right now we are planning to add the elliptic curve step of authentication, because the first step is still SHA signature.
Thank you.
Okay. Any more questions, colleagues? No? So please close your presentation. Thank you. Okay, colleagues, thank you for your presentations. It was very interesting. I invite you tomorrow in the morning. We will continue our section proceeding. So have a good evening and bye-bye. Thank you.
Thank you. Bye-bye.
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 Thank you very much. Bye-bye.